Okay. So my question to you is it a linear optimization problem or non-linear optimization problem?
It's not linear.
Take a look over
It's
here.
linear. Because of the logs, though.
It seems like it's linear, right?
But it's a sigmoid, so it's the log.
Sigmoid is what makes it non-linear.
Yeah, it's linear.
If the sigmoid was not there, then we'll have a closed form solution. Okay. So because of the sigmoid, anytime exponentials, logarithms are involved, it becomes a nonlinear optimization. So what would be the technique for solving it? Gradient descent. Okay. So now to find the gradient descent, what do we have to do?
Find the gradient.
Okay. So let's take a look at the gradient descent formulation. Okay, for the gradient descent, we'll start out with initial betas, correct? You can initialize them to some random numbers. Okay. How many betas will there be?
Depends on the features that you want.
Depends on the features. If you are analyzing some medical data where we have 10 features like weight, height, blood type, and whatever, then beta will be a 10-dimensional vector, right? So we initialize beta, then we go into a loop. So some number over here. And now we will do beta equal to beta minus alpha times delta of beta of loss of beta. So this inverted triangle
That operator.
is basically the derivative.
Yeah.
Or alternatively, I could write it as beta equal to beta minus alpha partial L of beta over partial beta. Okay, and we iterate over it until we find the beta. Okay, next question. Suppose somebody gave us a problem with 10 features, right? They gave us 10,000 training data. Then, in order for us to find the beta as we program it, what is the part that we do not know over here? Like I said, alpha, we will fix it in the beginning. That's the learning rate, for example, 0.1. Okay, beta in the beginning will be initialized randomly. Okay, so for us to keep updating beta, what do we do not know?
The gradient.
The gradient, the partial L of beta, right? Okay, let me see. If I can go 5 more minutes. Okay, let me go 5 more minutes at least, and then I'll give you a break. And then after the break, I'll show you the full code, show you the full result on some training data. Okay. So anyway, how do we find the gradient? Okay. So we know the equation for okay. So now let's go partial L of beta over partial of beta. Okay. So because so M is the number of training data, right? Okay, let me do this. If you take a look over this expression, right? H of x of I is this part. Okay, so don't I have to take the derivative of this term with respect to beta? Then derivative of this term. So let me call this part 1, part 2.
Yeah.
So suppose I say negative partial 1 over partial beta plus partial 2 over partial beta. Okay, so that we can easily isolate one part, compute the derivative, it would be pretty easy, right? So now if I go to the part 1 is yi log of h of xi, which is 1 over 1 plus e to the minus beta t x of I, correct? Okay, so, and again, partial over partial beta. Sorry, I just wrote 1. Okay, 1 is like this, right? So, isn't this log of a over b? So can't I write it as yi log of 1 minus log of 1 plus beta t x of I, right? Agree? What's log of 1?
0.
0. So wouldn't this become y of I? And there's a negative sign over here. Log of beta t x of I. Okay, now let's do, so this is our term 1. If we do partial 1 over partial beta,
I mean, did we finish? What about the,
Yeah, this is the first part.
so I'm just rewriting the part 1. Now I'm going to take the derivative, right? So if you recall, what's derivative of log of z?
1 over z.
1 over z, right? So this will become minus y of I,
1 over
1 plus e to the minus beta t x of I
times the derivative.
times the derivative of the inside with respect to beta. Remember, what's the derivative of e to the minus beta t x of I?
Minus.
minus x?
Minus beta.
Minus x of I, and the same thing,
Yeah.
right? So again, I can write it here, minus x of I, right? This minus minus cancels. Okay, so this becomes y of I, x of I over 1 plus e to the minus beta t x of I, k times e to the minus beta t x of I. You guys agree?
Yes.
Okay, so now let me give you one more mathematical trick which we'll be using off and on. Okay, so focus on this part. E to the minus beta t, forget the yi xi for the time being.
Yep.
So what I'm trying to say is e to the minus beta t x of I over 1 plus e to the minus beta t x of I could be written as 1 over 1 plus e to or sorry, 1 minus. 1 minus. Right? Am I right? This will be
Yes.
You just do plus 1 minus 1 and then
no, other way around. If I wrote it like this, then what will it be? It will be 1 minus 1 plus e to the minus beta t xi over 1 plus e to the minus beta
You
t
get a
xi.
minus though. So it was right the first time. It is 1 minus 1 over 1 plus e to the minus beta t xi.
No, it should be like this. See?
Because you get 1 minus 1 is 0, but then you have minus e to the minus beta t x of I.
Oh yeah, I wanted the minus.
Okay,
And
you
the
wanted the
reason
minus,
is, and the reason is, no, there is
No, there's no minus.
There's no
That's what I'm
minus.
saying.
Okay, my mistake. Then it should be the other way around. So then it should be 1 minus.
Yes.
Okay? What's this called over here?
That's the sigmoid.
That's the h of x of I, right? So as you can see, what will this turn out to be? Will be yi x of I and 1 minus h of x of I. So this is the derivative with respect to part 1. Everybody agrees? Okay, very similarly, what I'll do is, by the way, don't worry if you were taking notes or not, I'll give you, I forgot to mention, derivation. I've already put it on the website. So after the break, I'll show you, A to Z, and you'll see, as long as you understand it, okay? See, one reason I try to do the derivation on the board is if I simply showed you and went, look, here's first part, it doesn't sink in. See, this way I make mistakes, you guys correct me, we all learn better. So anyway, but after the break, I'll give you the whole solution where we take the derivative of it. In the end, there will be a beautiful compact solution such that if we now program it into the gradient descent, we'll have a very easy implementation of the logistic regression. Okay? All right, let me give you a break and then we'll continue from here.